step. For those of you who are watching the video, it looks like we're on the second page of the notes, and we had not finished those last two. And I want us to do those. Remember, what technique were we learning on Monday? What was it called? Integration by U substitution. Yeah. Now, so let's look at the first one, integral of 5e to the 3x dx. Now, is this a composition? Do you see a function inside a function anywhere? Yeah, there is. 3x is the exponent of e to the power. What can I do with that 5? I'm going to pull that sucker out. So I'm going to rewrite this as 5e to the 3x dx. Now I'm going to let u equal 3x. What's du? 3dx. Now the question is, do I need to include anything else in my integral? I need a 3 and a 1/3. So I need a 3 and I need to offset it with a 1/3. So what I have now is 5/3 times the integral of e to the u du. Now, do you have any questions about where any of that came from? What's the integral of e to the u du? Let me back up. What's the integral of e to the x dx? Let me back up. What's the derivative of e to the x? E to the x. So what's the integral of e to the x? E to the x. Okay, we're just going to stop right here. Oh, mercy. You slept 2 days? Well, we're going to better get it now. How do you take the derivative of e to a power? It's e to the power times the derivative of the power. Four times 2x e to the x squared, or 8x e to the x squared. Did I lose you there? Okay, now, well, what's the derivative of e to the x? E to the x. So what's the integral of e to the x? E to the x. So this is 5/3 e to the u. That's a constant. So that's 5/3 e to the 3x plus a constant. How can you check that? Take the derivative. What's the derivative of e to the 3x? Ignore this. What's the derivative of e to the 3x? 3e to the 3x. So it'd be 5/3 times 3e to the 3x. What's the derivative of a constant? 0. What's 5/3 times 3? So that's 5e to the 3x, which is what you have right here. That's how you can always check. Now, there may be a few of you who say, I don't need to do U substitution to do that problem. Fine, I don't care. Last one. Is there anything I could move out? Yeah, I'm going to move that 3 out. Do you see a composition anywhere? Where? Perfect. You're doing the square root of 2x squared plus 3. So what do I want to let u equal? So what is du? 4x dx. Do I need to put anything else in my integral? I need that 4. But I offset it with? So now I'm going to rewrite. I've got 3/4 times the integral of what? What do I replace all this crap right here with? What? That's du, right? 4x dx, that's du. And what's on the bottom? Square root of u. Good. Now, I don't like the way that looks. That makes me not happy. You can say, Dylan, you can say, yeah, now you know how I feel, right? No, I'm kidding you. Where did I just go there? I'm sorry. Now, I'm going to write this like so. I can integrate that. How do I integrate that? To the times because it's u to the 1/2 divided by 1/2. So what's this give me? 3/4 of 2, 3/2 times u was 2x squared plus 3 to the 1/2 plus a constant. If you want to write the to the 1/2 power as square root, that's fine. You got to practice, right? You got to practice. Now, this is where the author starts teaching you substitution. Well, snap. You already know u substitution. However, this problem has a little hitch in it. And I want to show you how the hitch works. We're just going to ignore his nonsense here. We're not even going to pay attention to it. We're going to work the problem. Now, do I have a composition? What's the inner part of the composition? So I'm going to let u equal 2x minus 1. So where do we want to put all this? Well, this stuff he's got here. Here's what we're going to do. Let's just put it under number 4. This is the integral of x times 2x minus 1 quantity cubed dx. We're going to let u equal 2x minus 1. So what is du? 2 dx, good. Do I need to put anything else into my integral? I got to have a 2. This part is going to become u to the 3rd power. This part is going to become du. I got that x sitting out there. Now, it's real easy to handle. I've got this x sitting here that you can't pull out a variable. What you're going to do is you're going to take that equation right there and you're going to rewrite that as x equals. How would we rewrite that? That's easy. How would we rewrite that as x equals? not 2u. U plus 1, all divided by 2. I have to add 1 to both sides and then divide by 2. Is that an O? Yeah, I understand. Or is that, okay. Add 1 to both sides and then divide by 2. That's what I'm going to replace that x with. It's all right, Esther, I promise. You've got this look on your face of, now, so here's what this mess is going to look like. I've got 1/2 times the integral. Now, this x right here is u plus 1 over 2, right? This is u to the 3rd power, right? And then my du. Now, believe it or not, that's not difficult. Let's get it to a place where you can see that it's not difficult. You see what I did? Did you say yep or nope? U plus 1 divided by 2 is the same as 1/2 of u plus 1. Now what can I do with that 1/2? Pull it out. What's a half times a half? So this is a 4th integral of, now look right here. Do you have any questions about how I got there? Now I can integrate. This is going to be 1/4 of, what's the integral of u to the 4th? Perfect. It's 1/5 u to the 5th plus, perfect. Don't forget the c. Don't forget the c. Now, we're going to substitute our u back in. Your question may be, do I have to distribute the 1/4? You can if you want to, but you do not have to. You can leave it like this. 1/4 times 1/5 of, I can't even remember what we put in for u, 2x minus 1. Now there's stuff you could do like factoring out a 2x minus 1 to the 4th power. You get this far and I'm tickled to death. Okay. Shoot, we're going to make it. I was wanting to get this lesson finished before lunch, and I think we can do it because this is the last one. Okay, now, again, throw a shoe. No, these shoes come off fast. I don't, no, because I don't know where my stuff just went. Where'd it go? Huh? Oh, there it is. Okay. I didn't mean to. I just am an idiot. Okay. Now, let's look at this thing. Integral of 2x plus 1 over square root of x plus 4 dx. Can I pull any coefficients out? I cannot. Why can't I pull a 2 out? because that 2 is only multiplied by the x, it's not a GCF of the whole numerator. Well, snap. All right, so fine. Do I have a composition anywhere? Where? So what's the inner function of that composition? That's what we're going to let you equal. So what's du? Oh, that's a nice one. All right. I don't need to stick anything else in there because du is just equal to dx. However, I got this whole numerator. Solve that for x. Yeah. X equal u minus 4. Okay, so let's see what we got. This is the integral of, let me go to a different color here, 2 times u minus 4 plus 1 over the square root of u du. Did I lose you anywhere? What in beans am I going to do with that? How? Yeah, I'm going to clean up that numerator, distribute and combine like terms. So that's going to help us start. What's that numerator going to give me if I clean it up? 2u minus 7 over u to the 1/2 du. No, du equals dx. Yeah, that's right, I subbed in. What can I do? Please tell me. Well, that's not it, but that helps always. But cry, no. Pray, cry. Okay, 3 strikes and you're out. What do we do?
Let's get out.
I could, and do what with it?
Move it up. So it's 2u minus 7 times negative 1/2.
What would I do with it then? I could do it that way. I could absolutely do it that way. Here's what Chase said. He said I could change this to u to the negative 1/2 and bring it up and distribute. I could do that. I need you, please, to remember that if you've got a single term in the denominator and multiple terms in the numerator, remember that you can split it. But what Chase said absolutely works. You absolutely could do that. So let's clean this up so we can go to lunch. What is 2u divided by u to the 1/2? 2u to the 1/2. Because remember, when you divide like basis, what do you do to the exponents? You subtract, and 1 minus 1/2 is 1/2. How are we going to write this? And that's what you would get if you brought Chase, if you brought that upstairs and distributed. That's what you get. All right, let's integrate. That fiddle, I don't want the symbol anymore. What's the integral or antiderivative of 2u to the 1/2? It's 2 times u to the minus 7 times but what did we let u equal? X plus 4. So this gives me finished with this lesson. Use substitution. This. I put a sheet of paper on your desk and it came out of your textbook. I had told you we were finished with this lesson. Please put your phones away. But I was glancing through your homework, the yellow, and I realized that the author still hasn't taught you how to do all the problems in the homework. And I got to looking and he just left a chunk out. How to do use substitution when you have a definite integral. And so this page has two problems that we'll do here in just a minute, but I wanted you to have the worked out answers there. If you would, just take this piece of paper that I gave you, flip it over, and we're going to work a couple problems back there first. And this is the first one we're going to do. I thought bad things about the author of this curriculum for a little bit. Yeah, okay. All right. Use substitution works exactly the same way whether you have an indefinite integral, meaning the plus c, or a definite integral where you have lower and upper limits of integration. But you do have something you have to deal with those limits, the 0 and the 1. First of all, let's start with the use substitution. Do we have a composition in there anywhere? Where is it? Under the radical. So what do we want to let u equal? So what is du? Negative 2x dx. Do I need to add or put anything else into my integral? Negative 2, yeah. So I'm going to get a negative 2 in right here and offset it right here. So this is going to become negative 1/2 times the integral. Now I'm not going to put 0 to 1, and I will explain why I'm not going to here in just a second. This piece right here is going to become square root of u, correct? And then this piece here and here becomes du. So this becomes square root of u du. Now, are you with me so far? Now here's the deal. Why did I not put any limits of integration? This 0 and this 1, the lower and upper limits of integration, are x limits because this is an x equation. I've turned it into a u equation. Those are not u limits, those are x limits. I have two ways I can do this. One way is I can change that 0 and that 1 into u limits by substituting them right here and figuring out if x is those, what would u equal? So let's go ahead and try it that way. My lower limit of integration was 0. If we change it to u's, what is my lower limit of integration? 1 minus 0 is 1. Now my upper limit of integration with x was 1. What would it be with u? 1 minus 1 is 0. You betcha. Are you okay that this 0 and this 1 are the limits of integration with respect to x because I'm doing it with x? I've changed all my variables to u. So now it's an equation with respect to u, not x. So I've got to make those limits be u limits, not x limits. How do I do that? I take the x limits and I put them into this equation right here and figure out if x was 0 and if x was 1, what would u equal?
So no matter what they equal, you said.
No matter what these are, if I have had to change my variable, I need to change my limits. Does that get you through the hump you were on? So I put them in here. If x is 0, 1 minus 0 squared is 1. So that new lower limit becomes 1. My upper limit was 1. 1 minus 1 squared is 0. So my new upper limit is 0. Now you say, well, Stennis, you can't go from 1 to 0. But I can, well, not inverse. I can flip it by doing what? So I'm going to change this, and I'm going to make it positive 1/2 times the integral from 0 to 1 of u to the 1/2 du. Now every one of you can integrate. This is going to be 1/2 times, what's the antiderivative of u to the 1/2? It's u to the 3/2 times 2/3. Oops. But now, look, I don't need the plus c, do I? Because I'm integrating from 0 to 1. I'm going to go ahead and multiply these together. So this is 1/3 times u to the 3/2 evaluated from 0 to 1. So this is 1/3 times, remember I'm going to evaluate this at 1 minus evaluate this at 0. What's u to the 3/2 when u is 1? And u to the 3/2 when u is 0. Remember, when you do a definite integral, you're going to get a number as an answer. Now, have you got that down? Now I'm going to show you the other way to do it. Okay. It's method number 2. I do exactly what I did before. This is the integral, negative 1/2 times the integral of, snap, u to the 1/2 du. We got right there, didn't we? And then we decided, or I decided to change the x limits to u limits. You don't have to change them. So let me show you. What if you say, oh, I don't want to change them. I want to keep them as 0 and 1. As long as you have changed the variable, you cannot write 0 and 1 down as your limits because those are x limits. They're not u limits. So what I'm going to do is I'm just going to leave it blank. I'm going to leave it looking like an indefinite integral. And I'm just going to integrate. So this is negative 1/2 times, what the devil is that? I don't know what that is. U to the 3/2 times 2/3. Okay. So I just integrated. Now I didn't put the plus c because I'm going to evaluate this thing here shortly. This is negative 1/3 u to the 3/2. Now here's what I'm going to do. I've got it finished. I'm going to stick the x's back in. What was u? 1 minus x squared. So I'm going to rewrite this as now that I've got the x's back in there, I can use my x limits. And I can evaluate this from 0 to 1 and not have to change the limits. So let's see what I got. I got negative 1/3 times. Now remember, I'm going to evaluate this thing at 1 minus evaluate this thing at 0. If I evaluate this at 1, 1 minus 1, 0, and 0 to the 3/2 is 0, minus, evaluated at 0, 1 minus 0 is 1, and 1 to the 3/2 power. What's 1 to the 3/2 power? What's 1 to any power? So that's 1/3 times negative 1. And that's exactly what you got doing it the other way. Long story short, either you decide to, when you change to u, you change your limits to u limits, or you say, I don't want to change them, I want to leave them, then you leave these blank until you get x back in there and then stick them back in. It doesn't matter which way you do it.
Are there certain times we're going to prefer one?
No.
So just practice whichever one.
Okay, let's try one more and then we're going to do the 2 on your paper. Okay, let's try, do I want to do that one? That looks like a pretty easy problem. I hope I'm not reading this wrong, but I think that looks pretty easy. Okay, here we go. Got a composition. What do I want to let u equal? X plus 1. So what is du? Good. So this is going to become the integral. Now I'm going to leave it blank for just a minute. Integral of what? Square root u du. You want to change it to u limits, or you want to leave x limits? Elisa, pick. X limits or u limits? U limits. All right, so we're going to do u limits, which means we're going to put numbers here. If x is 0, what is u? 1. If x is 3, what is u? Now, let's go get it done. The integral of u to the 1/2. So this is 2/3 times 4 to the 3/2 minus 1 to the 3/2. What's 4 to the 3/2? Square root of 4 is 2. 2 cubed is 8. Good. Minus. So this is what, 2/3 of 7? Which is, there you go. Questions? If we had decided to keep the x limits, then I would not have put anything here. Anything here. And I would have put my x plus 1 right back in there. 2/3 times x plus 1 to the 3/2. And then I would have evaluated that from, thank you, I got all messed up there, from 0 to 3. Okay. So if you're going to say, I want to put my x limits back, Just snap. Leave these blank because you never did change them to U limits, so don't put anything there. Do you have questions? All right, take a look at the paper that I gave you. You don't have to work through these if you don't want to because the answers are there. One of them is a trig function, and I thought we probably needed to do a trig function. Huh? I'm going to do a trig function. Integral from 0 to pi over 3 of tangent x secant squared x dx. It's easier for me to see all the stuff if I change secant squared x to secant x quantity squared. I can see it better. Do I have a composition? I do because I have something being squared. Well, tangent x is just tangent x. I mean, there's nothing being done to tangent x besides multiplying it by something. But if you'll...
Like if that was just the whole thing was secant x,
Mm-hmm.
x the
No, because if it's just secant x, if I let u equal x, and that it has a derivative of 1, so there's nothing to it.
if that was like tangent 2x, then there would be
Then we don't know how to do that problem in Cal 1. Here's the deal. I can look at that and say, I know I'm going to have to let u equal sine or secant x. And the reason for that is the derivative of secant is secant tangent. And so see the tangent is part of the derivative. So to help you see this better, I'm going to rewrite it like this. We're going to let u equal secant x. The derivative of secant is secant tangent. See, I've got all of that in there. So my integral, I'm going to leave it blank for a minute. I don't know what I want to do yet. Derivative of secant, wait a minute. Let me think for just a minute. There's something I want to make sure I'm doing right. I'm doing it, I'm not doing this right. I knew I was having a problem. I'm not doing this right. I knew I had something wrong. All right, so let's think about this. What if I let u equal tangent x? What's the derivative of tangent x? That's what I want to do, because the secant squared is sitting there. Yeah, I had this screwed up.
it's gotta be math.
Maybe. No, I'll go back and show you why. Because when I did what I did just a minute ago, I looked at it and thought that won't work, and that's why I knew I'd messed up somewhere. Do you remember the work we did 2 days ago? Sorry. Didn't have to be a composition to use U substitution. All the ones we did today were, but it doesn't have to be a composition to do a U substitution. Here's the deal. You will do enough of these where you can, like I looked at that and the stuff that I had done before and I thought, no, wait, there's something wrong. This is just not right. What you want to do if I let u equal secant x, so don't write any of this down because I'm going to show you where I screwed up. Then du equals secant x tangent x, right? Well, if I let u equal secant x, then that's u squared, right? I don't have this secant x part. I don't have it. And you cannot introduce a variable. You can pull in a 2 and a 1/2, but I cannot introduce a variable.
The way you had it written before, it was just
But see, that's why I had it screwed up, because this would have been u squared. So I didn't have an extra secant. That's why I had it screwed up. So when I realized that, I thought, no, wait a minute. If I let u equal tangent of x, what's du? Oh, it's secant squared x. The derivative of tangent is secant squared. Oh, snap, that's what it is. That's what I've got. So du is going to be secant squared x dx. I mess up. You guys have known me long enough to know I mess up. What am I going to have right here then? That's it. This is u. Secant squared x dx. All of this is du. Now, so we decide, do we want to do u limits or do we want to leave the x limits? Neither one of them is easier than the other one because we're still going to have to take tangent eventually. So, okay, so, okay, that wasn't too long. All right, so Caden says let's leave x limits. If we're going to do the x limits, then we don't put anything here because this is a u. How do I integrate u du? But remember, I can't say evaluated from where to where because I don't know. So I'm going to plug back in my x, tangent x, evaluated from 0 to pi over 3. Yeah, I guess it is. Dang it. Yeah, I left off the square. Okay, so this is 1/2 the tangent of pi over 3 squared minus the tangent of 0 squared. Now you got to think, what is the tangent of pi over 3? What is the tangent of pi over 3? There you go. I see the hand. The coordinates of pi over 3 tangent is what over what? Sine over cosine, y over x. So the tangent is, that's it. That's it. Square root of 3 over 2 divided by 1/2. Dividing by 1/2 is the same as multiplying by 2. What do you get? Square root of 3. So this is 1/2 times the tangent of 0. What's the sine of 0? 0. What's the cosine of 0? And so what's the tangent of 0? 0. And 0 squared is 0. So this is square root of 3 squared. 3, half of 3. It's 3/2. And I sure hope that's what we got there. Yeah. Yeah, it'd kind of be a problem if it flooded. All right. Let's look at one other one. Yeah, so Esther, the stuff that we did 2 days ago was not composition. So it's just going to take y'all to do your homework. Shoot. Time is my enemy right now. It is my enemy. Look at the last one on that paper. The integral from 0 to 1 of x over x squared minus 4 dx.
It's like perfectly in half.
That's pretty good. Now, so let's not think composition. Let's think it a different way, maybe. You don't have a clue how to integrate this thing without doing a substitution. You don't know what to do. I don't even know what to do if I didn't do a substitution. So you say, well, all right, so if I do a substitution, what would I let u equal? Well, if I let u equal x squared minus 4, what's du? 2x dx. Hey, I got an x in the numerator. That's what I'm going to do. So if u equals x squared minus 4, du is 2x dx. Do I need anything else in my integral? I can do that. 2. So this gives me 1/2 times the integral, and I'm going to leave off the limits for right now. What's my rewrite going to look like with my substitution? What's it going to look like? Du over u. And when you have du over u, I would encourage you to just write it like this. 1 over u du. Do you want to change the limits or leave them? X limits or u limits? U limits. All right. Dylan says u limits. So that means we're going to take these x limits, we're going to put them in here and figure out what the u limits are. If x is 0, what is u? If x is 1, what is u? Is that okay, or do I need to switch it? We're good. -4 is smaller than -3, so we're fine. So this gives me 1/2 of, what's the antiderivative of 1 over u? Natural log. Now here's where you have to be careful. It's a frickin' log. It's a frickin' log. Why did I put absolute value around it? Because I cannot take the natural log of a negative number. So you have to put those absolute value bars. So let's do it. This is 1/2 of natural log of 3 minus natural log of 4. Now there's one thing you can do. Did the author? Yeah, that's what I thought. There's one thing you can do. If this was a multiple choice question, that would not be the answer. You can condense when you have 2 logs with a minus between them. And you can condense it how? With a division. 1/2 times the natural log of 3/4. There you go. Okay. My original plan was to do a chunk of the next lesson. When I realized the author had not taught you everything in the homework, I realized I couldn't do what I planned to do. So You have got to practice with this. You go, oh, shoot. Um, we can't go on. You gotta practice. We can't go on.